Hi, Katja. Yes.
Great, thanks.
So good afternoon, everybody. I hope you can hear me well. And so welcome to this sixth webinar. And first of all, I really wish you a happy new year. I hope you enjoyed the Christmas break. I guess that it has been more calm than usual, but I still hope you could enjoy it. And so I hope you had a very nice start of the year. And we are really happy to start January with this sixth webinar. So the formula is as usual. So it is recorded and the recording will be put online. It will last more or less 1 hour. And here we will be, today we will be three presenters, Katja from Synergize, my colleague Philippe and myself. And there are also members of the consortium within the audience who are there to answer your questions and to help me managing the webinar. So the outline today is this one. So as usual, I will briefly remind what is Sen4CAP, and then we will have a first topic on the system. I will remind you what will be the version 2.0, which will be released in January. And also I will refresh your mind about the next release until the end of the project. So you remember that Sen4CAP will be completed by the end of March. And so we will explain you what we will do between now and the end of the project. And then we will have a presentation on the markers database. I will present you the database, listing the markers and explaining you how it will be organized and updated. And then Katja will show you how these markers will be accessed within the NIVA project. The second main topic will be on the result of the 2020 demonstration. So you know that the project is working with pilot countries, and during each year since 2018, we are running the system at national scale with these pilot countries, and Philippe will present you some outcomes of the last year. And then we will end with questions and answers and planning for the next month. So I will ask you to mute your mic during the whole webinar and to use the chat if you have burning questions. And in any case, after each topic, we will break and give you the floor to have a discussion and to ask your questions if there are. So let's start with the Sen4CAP overview. So what is Sen4CAP? Sen4CAP is a system, a set of algorithms which are based on a large data set of Sentinel-1 and Sentinel-2 matrix markers, which are computed at the level of each parcel and stored in a database along the season. Then these markers, this database, can be used in a variety of applications. Within the project, we have worked in a delimited framework, and so we are working with different use cases which have been defined at the beginning of the project, and you can see them, you can read them here on the right. So these use cases are mostly related to the greening payment. And so to support these use cases, we have defined and developed 4 main types of EO products. So the crop type mapping, growing vegetation indicators, grassland mowing detection, and agricultural practices monitoring. And these products are based on the markers. Here, during this last year, we have added the tillage detection, which is new. It was presented last time, and we will go on update you on this new product. And so, of course, the markers within Sen4CAP, the markers have been used for these 4 products and for these use cases, but they can be used for many other products and many other use cases. So the project was organized in 2 main phases. The first one was really about the design and the prototyping, where we selected the use cases, we defined the products, and we defined we developed a first version of the system. And then during the second phase, we have been demonstrated this system over 3 successive years, 2018, 19, and 20. At national scale over the agricultural seasons. And here during this demonstration, the focus has really been on the validation and fitness to use assessment, capacity building and training. So really qualifying the system and supporting the users to be able to operate it by themselves. So what is this system? Here is the overview. This is a diagram that you should know. So the Sen4CAP system is using Sentinel-1, Sentinel-2. It includes pre-processing, both for Sentinel-1 and Sentinel-2. For Sentinel-1, this is for sure mandatory. You need to compute the currents and the amplitude time series. For Sentinel-2, you have the option to directly use the L2A time series, which are provided by ESA, or you can run an alternative atmospheric correction processor, which is Maya, and process your L2A time series by yourselves. And then from these L2A time series and amplitude and currents, markers are extracted at the parcel level, stored in a database, and this database is used by the different processors to generate the different products. So, in summary, we are using Sentinel-1, Sentinel-2. This is object-based, and the key processor is probably the markers database, which can be accessed by all the processors. So this is a system which can work from A to Z in an automated way, but this is also rather modular, and you can pick the module that you want and run it individually. It is running on the cloud or also locally, and it can be run along the season, so in real time, or offline if you want to process the season at the end. So this is free, open source. You can see here the main software on which it is relying. And in terms of operation, we try to make it rather simple. So it means that at the beginning of the year, when the system is installed, you need to provide very few parameters. So you need to upload the shapefile you want to, the shapefile that will define the area that you want to monitor. You need to define the monitoring period, and you need to define if you want to include Landsat 8 in the sensors or not. Then during the season, the paying agencies are asked to provide some information. The first one is, of course, the subsidy application layer. So basically the parcels that you want to monitor. And then for each product, some parameters, either in the form of lookup tables or in the form of configuration files. The last slide of this overview is not about the tool, but it's about the users. So you can see here some figures showing that Sen4CAP has been tried by many users, either directly downloaded from the website or also tested on virtual machine on CreoDIAS. We are trying to support you in the use of this system, thanks to a forum, webinars, question and answer session, and some trainings. And we are, of course, always open if you have wishes that of events that you would like to get. We are ready to organize them. That's it for the overview. I don't know if there are some question on that, even if this is repetition. I see there is one question about Landsat 8. So the benefits or disadvantages of using Landsat 8. So Landsat 8 is 30 meters. So I would say that if you have not a very high cloud coverage, I would only stick to Sentinel-2. If there are a lot of cloud cover in your area, and so that the density of Sentinel-2 becomes rather low, having Landsat 8, if you have a cloud-free Landsat 8 images, this is already additional data, and so this is useful. So it will really depend, I would say it will really depend on the density of the Sentinel-2 time series during the key moments of the growing season. Okay, I will move to the second point. There is another question. So we are working on a CreoDIAS virtual machine. Yes, so all the demonstration that we did in the project is on CreoDIAS. And the test machine that we provided to the paying agencies were also on CreoDIAS. Okay, I will go on, and we go on with the questions at the end or at the next break. So the system evolution now. So the last version of the system which was released is the version 1.3, released in November. We had a question and answer session in December, and so I think that it was already well presented. And so the next one now is the version 2.0. So version 1.3 was really mainly corrections, adaptation, and some improvement, but there was nothing really new in the version. But here we will do a major update. So we are directly switching to the version 2.0 because there will be very big evolutions. And so the main ones are the fact that it will include the markers database, the new processor about the tillage monitoring, which I mentioned at the beginning. And there will be also the Dockerization for different Sen4CAP components, which are listed here. So processors, utilities, Snap 8. There will be the support for the new version of Maya, and also the integration of a new DEM for the European Northern countries, which are not covered by the SRTM. This is the main features of this version 2.0, so that it will be released at the end of January. This is for the version 2.0. And the next one that we plan to release at the end of the project will be the version 3.0. And here again, we plan to do a major update. So not a version 2.1, but a 3.0, because all the web interface will be updated. It will be fully implemented. Here you can see in HTML5 and JavaScript, and it will really improve the visualization. So you will be able to extract the markers by parcel in the web interface. And so that will be something very more useful to play with the products. This is the plan until the end of the project. This was already presented, so there is really nothing new on that, but this is just to put us all on the same level. And so I will go on directly with the markers database, and then we will break for the questions. So a main new item that will be included in the version 2.0 is this database of markers. So what we call markers in Sen4CAP, and so I think this is important to define it, because maybe this is not exactly what is defined in the GRC guidelines. So we make the distinction between what we call the base markers and the practice markers. So the base markers are values which are directly derived from Sentinel-1, Sentinel-2 time series at the parcel level. And the practice markers, this is the interpretation of these base markers to monitor different practices. So this is an internal language in Sen4CAP. And so here for the base markers, here are the markers which will be derived from Sentinel-2. There are markers that will be derived, extracted for each parcel at each acquisition, for the NDVI, for the FAPAR, for the F-cover, and for the LAI. This is the average and the standard deviation at the parcel level for each acquisition. Then we have the reflectance bands, B3 until B12, and the DWI and the brightness. And for these channels, what we store is the mean and the standard deviation by parcels of a 10-day interpolation of the value. So this is not at each acquisition, but we interpolate the time series every 10 days at a fixed date. And this is this interpolation, which is averaged at the parcel level with the standard deviation, and which is stored in the database. From Sentinel-1, we have also here single date base markers. So you can see amplitude, coherence, so in ascendant and descendant mode, and for VV and VH, and the ratio. And so for each acquisition, the mean and the standard deviation at the parcel level will be stored. And also the weekly average. So the average of the values during 1 week is computed for each pixel, and then the mean and the standard deviation is computed by parcel and stored in the database. Then we have also a monthly average. So the same logical. So for each pixel, we will compute the monthly coherence VVVH and the monthly quantile 10 in the coherence VVVH, and then there will be a mean and a standard deviation by parcel. Again, a new set of base markers, which are bimonthly average. So these are more temporal features, and you can see here. So these are mean values, and COV means coefficient of variation of the amplitude, ascending, descending mode, and VVVH, and the ratio of the amplitudes. And the last temporal markers from Sentinel-1 are seasonal average. So over the full cropping season, the temporal standard deviation of the currents VVVH are averaged by parcel with the standard deviation. So all this information is derived from Sentinel-1 and Sentinel-2 over different time steps. So each table is one time step, and this is stored in the database, and the database is updated each time there is a new value. So these are for the base markers. These base markers can be used, are in fact used by the Sen4CAP processors for the crop type mapping, for the grassland mowing, and for the IFA practices, but they can be used for many other applications. And in the database, we also include practice markers. So this is the interpretation of the base markers to monitor the practice. And here, this is the markers which correspond to the harvest markers for the agricultural practices processors. So you can see here, and so from M1 to M5, so there is a typo here in the table. Presence of vegetation, loss of vegetation. M1 and M2 are based on NDVI, so from Sentinel-2. And then M3 to M5 are based on Sentinel-1, and they will indicate the loss of vegetation or presence of vegetation based on the backscatter ratio, or the loss of vegetation based on the currents. And so these markers will also be included in the database and are updated weekly along the season. This is what will be in this database. And so here, if I come back to the general overview of the Sen4CAP system, you can see here that this database corresponds to what we call a processor, and then this processor can be accessed through different interfaces and can be used for different purposes. So in terms of here, the design of this database, so this is really an internal organization, but depending on the type of input for the markers, we are working with different products. So L3B, meaning LAI, FAPAR, FCover, amplitude and coherence is in one group. Then you have amplitude ratio, then the Sentinel-2 indices and spectral bands, and then what is needed for the coefficient of variation. Access to this Sen4CAP database can be done through REST API adding endpoints, and from this you can retrieve the parcel properties in terms of markers from the LPIS, and also retrieve markers, time series of these markers for the different parcels. This is what will be designed and what will be available in the version 2.0. And then I will give the floor to Katia, that will present you how it is used in Niva. And that will be an example of how this database can be exploited. And then we will break for questions. So Katia.
Yes.
Yeah.
Okay, hello everyone. I'm Katia Baetz from Synergize. I will present OpenAO as an interface to Sen4CAP data that are used in the Niva project. So this is tightly connected to the markers and how to access them, and I will explain that link at the end. Let me just first briefly tell you some basic things about the Niva project. So it's a H2020 project which started mid 2019, and it will end in May 2022. And NIVA stands for New IX Vision in Action, and even this name explains the overall objective of this project, which is modernization of IX by making efficient use of digital solutions, by creating reliable methodologies, and by producing some harmonized data sets. All of that for the purpose of monitoring agricultural performance. This project is quite ambitious. It has it has 9 paying agencies as, let's say, the main partners, but there are more than 25 partners there, because each of the paying agencies is collaborating with a technical partner, at least one, sometimes more. The core of this project are the 9 use cases, which can be kind of grouped in 3 main parts, which is seamless claim, self-certification, and monitoring. I will not read all of them. I would just like to expose or mention specifically 2 of them, because 2 paying agencies decided to use the Sen4CAP system as one of the tools supporting their use case. So they're producing some data, and then they are applying some further analysis on this data within their use case. So one is the pre-filled GSA application led by Lithuanian agency, also the pilot agency of the Sen4CAP. And the other one is the French paying agency working on the agro-environmental monitoring use case. I will stop here, and you can read some more information on the website if you wish. Next slide, please. So as I said, this project is it's huge, right? It's involving many partners, and each of these partners is building their proprietary APIs. So there's a dedicated effort within NIVA to provide some common interfaces that would be used by all of the NIVA components. And OpenEO was chosen as one of such interfaces. So what it's all about, the OpenEO is an API, and it connects the R, Python, and JavaScript and other clients to the big Earth observation cloud backends. Just to list a few providers compatible to OpenEO, these are CreoDias, EODC, Google Earth Engine, Sentinel Hub, and Vito, and some more. So the main motive for development of such API was the fact that the OGC APIs like WMS and WFS, they were not appropriate anymore to address the complexity of the Earth observation data that we are dealing with nowadays. This OpenEO API was developed within some separate project, which ended already, but the consortium is still working on it and using it further. So the Sen4CAP products that have been or will be generated for NIVA will be available and exposed also in this OpenEO API for further analysis. What you can see here on the screen is the web interface, which is a good starting point for someone without not familiar with the programming. But as I said, there are client libraries for JavaScript, R, and Python in scope of this API. Next slide, please. Yeah, so this is example or let's say a demo of how one could expose Sen4CAP product in OpenEO. In fact, let's say that we have some raster images produced by Sen4CAP, for example, raster images with the vegetation index values, and this data is then stored in the on DIAS using the capability of DIAS of storing the user generated raster data, and this is called BIOC, just as a short information. And anyway, when you have these data stored on DIAS, then you will just have to define the input data, so the spatial and temporal range you are working on, and then some functions you will want to apply on this data. Some are already predefined, but some can be developed by any user for his own use. And then you define this the input and the processes in form of such JSON, and then you run the processing, and you can see the preview of the result, for example, as an image, if this result is an image, like you see it's there on the right side. Next slide, please. So this, what I explained earlier, is something that you would apply for some simple processing, but if you wanted to have some large-scale calculations in terms of data and in terms of complexity of processing you are doing on this data, then a better approach would be using the batch job, which you could graphically define with these three boxes we have here, whereas the first one we have the input data, and then in the middle we would define the processing that should be done on this data, and then the right hand box is defining the format of the result that we are going to generate. So this is just one example when we are applying some additional processing on the raster data Sen4CAP provided, but in terms of, for example, the markers API that Sophie mentioned earlier, so all those resources that the API will provide in Sen4CAP, they will also be supported in OpenAO interface. And from my side, this is everything. Thank you.
Thank you, Katja. I propose to have a break here for questions. And so if you have, don't hesitate to unmute. This is sometimes easier than the chat. Is there any question on that? So the systems, the database, the OpenEO. No question. All right. Okay, so I would propose that we can move to the next topic, and then we can come back at the end if there are more questions on these aspects. And so for the next topic, I will give the floor to my colleague Philippe, who will share the screen.
Good afternoon, everyone. Do you see my screen?
Yes.
Yes. I'll put it on the screen. Yeah, so as Sophie said, I'm going to present to you the main outcomes of the 2020 demonstration with our pilot countries. And I was a bit behind schedule for the preparation of this presentation, so I will try to do my best to be as clear as possible and not too long. And so in 2020, we decided to adopt a quite flexible approach with our pilot countries, following their needs and wishes, with different kind of involvement from them and from us in terms of support. First, there was a first group of countries on the right, so Czech Republic, Lithuania, and Romania. They still wanted for us to operate the system with the fine-tuned parameters that we defined in 2018 and 2019. And also for Lithuania with a dedicated production plan to be able for them to integrate the results of the system in their workflow for the control by monitoring of them. Then two countries, Netherlands and Italy, they wanted to try in 2020 to operate the system by themselves with our support. And at least for Netherlands, we also provided the virtual machine with the system. Then Castilla and Leon is a specific case because in 2020 they already integrated one of the module of the system, so the classification module, in their workflow, and so they used the results in their workflow. And finally, France, they didn't have much time in 2019 to look at the results and to validate them, so they wanted to use this year and 2020 to look more at the results and make a deeper validation. And so in this presentation, I will mainly present the results of the countries where we operate the system by ourselves. In terms of ICT, there was ICT settings, there was a question about that. So as the other years, we used virtual machines that are running on FreoDIAS and one virtual machine by country with these settings. So there were two configurations, so a lower configuration for the small countries and a higher configuration for the big countries. But in 2020, because we reduced the size of the monitored area, even for the big countries. So for Romania, the lower configuration would have been enough for the production with the operating system Sen4S and with the normal Sen4CAP installation, of course, with the update when a new version was available. And so for these 3 countries that we operated by ourselves inside the consortium, these are the number for the pre-processing. It was just to remind you that the number of Sentinel-2 and Sentinel-1 data that have to be pre-processed are quite high. And so it's important to take that into account when you begin a season. So either to begin quite early the pre-processing of the data, or either to adapt the settings of your machine to be sure to have all the data pre-processed when the parcels are coming and when you want to process more advanced products. And for each Sentinel-2 acquisition, the system automatically process the vegetation status products to the NDVI, LAI, FAPA, and FCOVR. Then concerning the planning, so I told you that with Lithuania we had a specific plan, and here's the plan of this processing, and it involved the continuous ingestion of parcels datasets. So as soon as they had some parcels ready, they would send these parcels to us, and then we had to import these parcels in the system, and when they had more, it was done again, and more parcels were imported in the system. It's of course involved the continuous delivery of products to the paying agency, and this enabled the paying agency to integrate the results to their workflow. And here you can see the number of parcels that were ingested through the season to reach the 100%. And the dots, the green dots, represent the different deliveries that have been done to the paying agency for the 3 main products, which are the crop light map, the grass and mold detection, and the FA practices monitoring. For Czech Republic and Romania, it was a bit different because they decided, the 2 paying agencies, to wait to have all the parcels ready to begin the production. So for Czech Republic, we received the parcels beginning of September, and from that date we simulated a continuous monitoring by providing different also products for each of the main products, just to make a simulation of a continuous monitoring, taking into account only the data, the EO data before these dates. And the same with Romania. And there we monitored 2, not the whole country, but 2 strata, which are represented here. So that's it. And now I will present to you the different products. So one example of these products, and then I will talk about the validation results and the number of parcels that were monitored for each country. But so the first one is the crop type map, and what is delivered for each product is something like this, with first a shapefile with the results of the classification. So the 2 predictions that are done with the classification, with the 2 associated confidence level, the results of the conformity assessment, which is on the parcel level using the results of the classification. So is the prediction conform with the declaration of the farmer? And finally, also the results of the crop diversification assessment, which is done at the holding level, using the conformity assessment, which is done on the parcel level. Also, we provided each time a predefined symbology for the shape, We also copied the crop code lookup table, which is the table which enables to group classes together for the classification. The results of the crop diversification assessment that's in a table and with one line for each holding. Then also we provide auxiliary information about the classification and the validation of the classification, and finally figures and statistics about the number of parcels in the different assessments that are made. And now I'm gonna just rapidly show you how it looks like these different projects. So the first one, the shapefile. You can see here, which is what is represented is the conformity assessment, which is done on the parcel level with the different indication. And on the lower left, the table. So you can see the declaration, CC declare is the declaration of the farmer, the prediction of the classification, which is associated with the higher confidence level, the second prediction associated with the second higher classification confidence level, and then the conformity assessment at the parcel level and the crop diversification assessment at the holding level. Here you can see that in fact all the parcels that are classified are conform. So the first prediction is the same as the declaration, except for one here which was not classified, and in this case the reason why it is not classified is given here also. Then we also delivered validation results. So for the classification, a part of the parcels are used for the calibration of the classification model. Then this classification model is applied to all the parcels. And the parcels that are not used for the calibration are used for the calculation of the validation. So first, the confusion matrix, which enables to calculate the overall accuracy, and also this figure with the F-score by crop type. And on top of that, there's also a table which summarizes all the crop types that were classified, and with the area and the count of a parcel. Now, if you have this figure on the right, you, in fact, there are two tables that enables to explain why the scores are low in some crop types. So if you see here the figure, for example, the lucerne and clover have quite low F-scores, and using these two tables, you can understand a bit more why it is the case. It's mainly because the confusion, the producer accuracy is low. You can see here that in orange, and it is because most of or high proportion of parcels from lucerne or clover were confused with the grassland crop type. So these are two tables to confusion producer and user, which enable to a bit give some explanation why the scores are low or high. Then the results of the crop diversification assessment look like that. So you have the holding ID, the category where the holding belong to, and then the diagnostic at the holding level. And here are the different values that are calculated to make this assessment. And this you can refer to the ATBD to understand how this is done. And finally, also, you get figures and statistics concerning the number of parcels that are conform, not conform, in terms of number, but also in terms of area, and a bit the same for the crop diversification assessment at the holding level this time. What I wanted to add also for the crop type is that for these 3 countries, what we did, so first we made classification with Sentinel-1 and Sentinel-2 markers, but then also we did a second classification with only Sentinel-2 markers to beneficiate from the lower resolution of Sentinel-2 pixels, and it enables to increase the number of parcels that are classified, and sometimes the numbers are quite big. So, for example, for Romania, the southern stratum, it enables to increase by 25% the number of parcels that are classified because of the second classification with Sentinel-2 markers only. And in terms of number in the different countries, so here you can see the number of crop types that are classified in each country or region, and the overall accuracy of this classification. And here I wanted just to list a bit some elements that explain why there are sometimes quite big differences in terms of overall accuracy between the countries. So the first element is the fact that you can group more or less the crop classes, and it has an impact on the overall accuracy. So it will depend on the degree of grouping that you do in the crop code lookup table. What also influences the overall accuracy is the delineation of the parcels, is it precise or not. The purity of the parcels, are there many parcels with 2 different crops in fact or not. The climate also has an influence, the diversity or biogeographical condition, the diversity of agricultural practices among the monitored area, and also if there are a few dominant crops, of course, and less minor crops, the overall accuracy will be higher. So all these elements have to be taken into account when you compare the overall accuracy between different regions or countries. Then the 2 family of products is the grassland mowing detection products, and for each of them, first we delivered a shapefile with the number of detected mowing events, and for each of these events, the date which was detected, and finally also a conformity assessment regarding the rules that were defined by the paying agency, and also a README file which explains which are the different grassland classes that are monitored, with which rules, and the explanation of each attribute fields. And so for the shapefile, it looks like that. Here, what is represented is the number of events, of mowing events that were detected. And in the table, you can see here the number of events, then the first mowing event with the date, the confidence level which is associated with this mowing event, and the information if this mowing event is detected by Sentinel-2 only, by Sentinel-1 only, or by the 2 satellites. And if there is a second mowing event during the season, you can see it here, and then a third, and then a fourth, and a compliancy assessment at the end. And here is an example of a README file where you can see the different rules that are associated with each crop code and the explanation of each attribute fields. And these are the numbers of parcels that were monitored in each country. And what we wanted also to add for these products is the fact that in Kenya a test was done using only Sentinel-2L2A pre-processed with Sen4CAP. So these data are available on Sci-Hub, and it's possible with the system to import them automatically. But what was observed is the fact that the cloud mask, at least in Lithuania, the quality of it was too low, and it created many false detection of glass harmony events. The EGEOS team also tried to develop a morphological filter to enlarge the cloud mask from Sen4CAP, but it was not successful. So in this case, in Lithuania, it was really needed to use L2A products from Maya instead of from Sen4CAP, which is an observation that can be useful for you also. And finally, the third family of products are the agricultural practices monitoring products. And here is an example of one of them. So first, there's the package shapefile and CSV, which contain the results of the practices monitoring with the harvest detection markers first, then the harvest detection week, and also a harvest detection week with Sentinel-1 markers only, and then the practices markers, and finally a compliance index regarding the practice. And a second output is the time series values for each parcel, so the DVI, backscattering ratio, VP/VH, and the coherent VV values for each parcel at each acquisition that you can use to, for example, to make figures. And you can see that these products are delivered for each monitored practice. So the harvest detection for the annual crop, and then the specific practices, so catch crops, fallow lands, and nitrogen fixing crops. And here is an example of a catch crop product with the compliancy index and different level of compliancy, and the table that comes with it, with the 5 markers for the harvest detection, the 5 first one, the harvested week, which is detected, harvested week with Sentinel-1 only markers, and then the markers that are used for the practice, and in this case for the catch crop, with the compliancy index at the end. And also with that, README file was delivered with the explanation of the different attribute fields from the shapefile. And the second output that you get is the different values, and from them you can recreate a figures where you can see for each parcel. So here the NDVI in green, the backscattering ratio in red, and then the coherent VV in black. And you can see that the harvest week was detected in blue here, and the practice had to be monitored inside this gray period. And so these are regular products that you get from the system if you run it on your own, and so you can make these outputs quite easily from this. And concerning the L4C, I just had the time to produce the results for Lithuania and Czech Republic, and here you can see the number of parcels that were monitored for each of the practice. And this is it on my side. Don't hesitate if you have any questions.
Thank you.
And there are some.
Any question for Philippe? So there have been some discussion in the chat, but I think different questions have been answered. There is a question from Marie. Is there a script available to plot this time series? Can you just clarify? You can unmute, but yeah. This is which time series are you talking about? There is a question from Thomas about the grassland mowing product. Why is the range of the confidence level for Sentinel-1 set between 0 and 0.5 and for Sentinel-2 between 0.5 and 1? I don't know if Laura is there. No.
Otherwise, I can explain it.
Please.
It was defined like this in the processor because from the validation, it came out that the detection with Sentinel-1 only was a bit less reliable than Sentinel-2, and so it's why they decided to make this split, so between 0 and 0.5 with Sentinel-1, and from 0.5 to 1 with Sentinel-2. It's more a definition from the processor. And about the time series, I guess it was a question from Marie. I guess it's referring to the plots from the L4C. And I'm not sure, maybe Cosmin, I don't know if you're there. I don't know if there is a code to plot or to make this figure.
The system is returning just the data available, and after that, the visualization tool is performing these plots. But we don't have a script that produces these images directly.
It should not be too complicated. Because in the XML, everything is really well arranged. So you could include this XML in, for example, R script or Python script to create these figures.
Yes, the system is also exposing an endpoint, HTTP endpoint, that is returning the data for this data for a parcel. So after that, you can take those data that are exposed as a JSON and plot them even in Excel or something.
Okay. All right. I will move to the last section of the webinar, just to give you the last information, and then we can continue the discussion if there are open topics. So, as I told you at the beginning, the next main step for us is to deliver the version 2.0 of the system by the end of this month. So you will receive an email, and it will be also posted, everything will be posted on the website as usual. The next webinar is within 2 months from now, so the 2nd of March 2021. Here there is a question, so the system will be released end of January. Depending on the questions we have on the forum on this version 2.0, we might organize the question and answer session in February. I think this is still open. It will really depend on how this version 2.0 is handled by you. That's it. And a last information that I wanted to share with you is that, in order to organize the end of the project, we would like to organize the user workshop in March 2021. This workshop will be, of course, open to our pilot countries, but we would like to make it fully open. And so if you are interested to participate, you will be able to register and to attend. And so this workshop we would like to organize as first a presentation of the summary, the main achievements of the project. So that will be presentations from the consortium, but we would like really to give the floor also to the users, so to the pilot countries, and maybe to some of you. That would be great if you could actively participate. And so having let's say a day of presentation showing what has been done so far with the system. Depending on the number of presentations, we can have half day or let's say a short day of presentation. And we would like also to add a half day of technical presentation of what is new in the system. So version 2.0, there will be new big evolutions, and the same in the version 3.0. So at the beginning of 2020, we were able to organize a hands-on training where you were invited in Louvain and where we present you the system. Then we had some other online trainings to continue this capacity building. And so here, this is a way to start a little bit the same kind of presentation on the new developments that were done in 2020. So this is a bit the way we see this user workshop. Of course, if you have suggestions or if you would like to participate, we are really open to your comments. And so the date is not yet decided, but it will be fixed rather quickly. And that's it for us. If there are any questions, any comments or suggestions, feel free to unmute or to use the chat. There's still question on the classif R. I propose that you go on the chat on this very specific question.
It was.
Yeah, Philippe.
It was answered by Diane already, but the classifier is a product of the crop diversification code. So you need to launch the crop diversification code, and it is explained in the sum how to do it. And then you have the three outputs, so the classif R, and then the crop diversification assessment.
There is a question from Emmanuel. Is there any change made to the markers algorithm? And so, no, these are already the same markers as in the L4C processor. In fact, these markers are used in the new tillage detection algorithm. And so these different ways of using it, but the markers are really the same. Okay. I propose to stop here the webinar, and we the consortium members will remain 5 more minutes if there are last-minute questions. So I thank you very much for attending the session. I hope you found it useful. So the recording and the slides will be put online, let's say tomorrow or after tomorrow. And you will hear from us by the end of the month with the system 2.0. In the meantime, if you think you would like to actively contribute to the workshop by sharing some experience, sharing some results, please contact me by email, or you can contact the generic, you can write to the generic Sen4CAP address to inform me. That will help us setting up this workshop. So thank you very much and have a nice afternoon. Bye-bye.
Thank you. Bye-bye.
Bye. Thank you.